Okay, last video that we have here, we've got 5 over x squared minus 7x plus 12 equals 2 over x minus 3 plus 5 over x minus 4. Okay, so again, this does have a special case, but as far as everything goes at the beginning, everything that we are doing at the beginning is still the exact same. So we need to factor the x squared minus 7x plus 12. If you haven't already done so, go ahead and pause the video and factor that. Go ahead and get a good practice with that. Okay, hopefully you have that bottom part of that factored now. You guys would see that that does factor to an x minus 3 times an x minus 4. Okay, so the x squared minus 7x plus 12, you should get x minus 3 times x minus 4 equals 2 over x minus 3 plus 5 over x minus 4. Okay, so what would our common denominator be that we need to multiply everything up here by? Well, I think we can see that each of them has an x minus 3 and each of them has an x minus 4. Okay, so we should multiply by that on everything so that we can see what all is left. So again, going to show the big long step here. X minus 3 times x minus 4 over 1 times my 5 over x minus 3 times x minus 4 equals, I got my x minus 3 times my x minus 4 over 1 times my 2 over x minus 3 plus, again, my x minus 3 over x minus 4, or sorry, x minus 3 times x minus 4 over 1 times my 5 over x minus 4. Okay? So again, things that will cancel. First one, we got a lot that'll cancel. Both x minus 3 is gone. X minus 4 is gone. So I am left with just a 5 equals, my x minus 3's are going away. Gives me a 2 times an x minus 4. Okay, now my x minus 4's are going away. Gives me a 5, and again that was a plus 5, times an x minus 3. And again, technically it's x minus 4 times 2, but I'm just changing those so that it looks like it's the order that we're used to seeing. And we can change the order because of multiplication. The order doesn't necessarily matter. Okay, so anyway, I'm going to go ahead and solve. 5 equals 2x minus 8 plus 5x minus 15. Then I am going to need to combine my x's together. So 5 equals 7x minus 23. Add 23 to both sides. I get 28 equals 7x. And x equals 4. So a lot of you guys are probably looking at that and you're like, that's the exact same as the last one that we did. Well, I'm going to tell you that x equals 4 is not the correct answer. The correct answer for this problem is no solution. So I want you guys to pause the video and think for a second. Why would the answer to this problem be no solution? So I want us to remember our domain. And remember that the issue of the domain is we have to make sure that the bottom does not equal 0. Okay? So I'm paying attention to the bottom of the fractions there. If I plugged in a 4 equals x, so if I plugged in a 4 for x up there, would there be any of those problems that would cause us an issue? That one right there would. Because if I plugged in that 4 for that spot there, I'd have 5 over, and I plugged in my positive 4, so 5 over 4 minus 4 results in a 5 over 0. Okay, so we do have to be aware of these problems that we're doing and make sure that they are not, make sure that they do not result in zeros afterwards. So I should have been telling you guys that all along, but none of those that we had so far were concerns. So that's why I didn't bother with it. You guys can see this one here. We got y equals negative 1. Negative 1 plus 3 is 2. Negative 1 plus negative 4 is negative 5. And we already know that negative 1 plugging in both of those were fine. So no concern on that one. Okay, next one up here. Again, we got 5. 5 plus 2 is 7. We're okay. 5 minus 4 is 1. We're okay. And then again, that's 7. That's 1. So we would be okay with all those answers before. But that is something that we have to be aware of and check when we are solving these problems. I'm not going to tell you guys that you need to go back through and make sure that you check every single one of them, but do be aware that that is a possibility. Okay? The last one that we have is going to result in having 2 answers. So there's less factoring, so that's got to be great, right? Well, when I multiply this, I'm going to multiply everything times a common denominator, which the common denominator for this would be b minus 4 and b minus 3, because this one would need a b minus 4 and this would need a b minus 3. Okay? So I'm going to multiply everything by that. So I've got a b minus 4 times a b minus 3 over 1. And I am multiplying that by a 4 over b minus 4 minus, I've got a b minus 4 over b minus 3 over 1 times a 3 over b minus 3 equals, and then again I got a b minus 4 times a b minus 3, and I don't really need to put that over 1 because I am just multiplying this times the whole number 1. Okay? So we look to cancel. B minus 4's cancel. I'm left with 4 times b minus 3 minus, now my b minus 3's will cancel. So I've got a minus 3 times a b minus 3. And then that's going to equal a 1 times b minus 4 times b minus 3. Okay? So we're going to go through and distribute to simplify this thing. 4b minus 12, nothing's crazy yet, right? Negative 3b, don't forget that's a negative 3 when I distribute, so that makes it a positive 9. Okay? And then here's where the tricky stuff starts. Well, I've got a 1 times, well, I don't even need that 1 there because 1 times anything is just itself. But now I'm going to have to FOIL. I'm going to have to take b times b, which is b squared. B times negative 3, which is negative 3b. Negative 4 times b, which is negative 4b. Negative 4 times negative 3, which gives me a positive 12. Okay? So here's where the tricky stuff's going to start happening. 4b and negative 3b, I can combine those together. Those are like terms. That gives me 1b. Negative 12 and positive 9, those can combine together. That gives me a minus 3. Okay? And then on the right side, I have a b squared minus 7b plus 12. And I cannot combine the b squared and the 7b because those are not like terms. Remember, the exponents also have to be the same if you're wanting to combine them. So what we have up here is we have a problem with a b squared and a b. And if you guys think back to Unit 3, you'll remember that the only way that we can solve a problem that has a b squared and a b, or an x squared and an x, is what we usually said, is you are going to have to factor. So I'm going to have to factor to solve this problem. But before I factor, I have to make sure that my problem equals 0. So we are not ready to factor yet. I have to make it equal 0. So I need to subtract b to both sides. And I need to add 3 to both sides. And when I do that, I end up with a b squared minus 8b plus 15 equals 0. So since I have a b squared minus 8b plus 15 and it equals 0, now I can go ahead and factor. Okay? So I'm going to factor b squared minus 8b plus 15. I'm going to change my colors. I'm going to write it up over here on the side where I got a little bit of room. B squared minus 8b plus 15, and that equals 0. So I'm going to do 1 times 15. What are my factors of 15? And I need those factors of 15 to add to give me that 8. Well, 3 plus 5 would give me 8. So that's a b squared, and that gives me a 5b and a 3b plus 15. Okay, it's kind of hard to see there, but that is, you can tell it's a negative 8. So I need both of those to be negative there. What can I pull out of these first two? Well, I can pull out a b. Leaves me with a b minus 5. What can I pull out of these second two? Well, there's a negative there, so I got to pull out a negative, and I can pull out a 3. I don't know why it's doing this, guys. And then we do this. Okay, and now we're back. So I can pull out a negative. Whoops. Gotta get my pens back working. I can pull out a negative 3, which leaves me with a b minus 5. So my two factors are b minus 3 times b minus 5. And remember, the whole time that was equaling 0. Whole time that was equaling 0. So now I get to set each of these factors equal to 0. b minus 3 equals 0. b minus 5 equals 0. And that gives me b equals 3. And that gives me b equals 5. Check. Does that work? Can b equal 3 and b equal 5? Well, b can definitely equal 5. Can b equal 3, though? Nope. B cannot equal 3. So that one actually doesn't have two answers. It just has the one. Okay? It cannot equal 3, but it can equal 5. Okay? And that is it.